The story of Chem High School. Welcome to Chem High School, a place where chemical elements get educated and learn more about chem world. There are many different elements in the school, for example, carbon, ferriiron, oxygen, hydrogen, nitrogen, and many more. Now let me introduce to you today's class, Mr. Formi's physical empirication and mollification with formulas.
Today, Mr. Foamy and his elements are playing Formulify.
The elements find their empirical and molecular formula members with a given percentage composition mass or the molar mass of different elements. But Mr. Formy, what are empirical and molecular formula?
Excellent question! Now let me tell you all what you want to know about these lovely formulae. First is empirical formula. Empirical formula is the symbolic representation of the simplest ratio of elements in a compound. It is sometimes called the simplest formula. For example, all of CH2, C2H4, C3H6, C4H8, and C5H10 contain twice as many H's as C's, and therefore the empirical formula for all of these is CH2. To find the empirical formula, we need mass percentage of different elements in the compound.
Can you show us how to find the empirical formula?
No problem. Alright, Ferri and Oxy, please come up here. Now let's assume that in the empirical formula of Fe, X, O, Y, X and Y are the variables, exist in the following mass proportion: 70% Ferri and 30% Oxy. First step into finding the formula is to meet our lovely number, Mr. 100 grams. Assume your group weight is 100 grams so that mass of Ferri equals 70% of 100 grams equals 70 grams. The mass of Oxy equals 30% of 100 grams, which is 30 grams. Then let's have a reunion with our best friend, who is also our principal, Mr. Molly. According to Ferri and Oxy's student cards, there are 55.85 grams of Ferri in 1 mole of Ferri, and 16 grams of Oxy in 1 mole of Oxy. From this, we can calculate that there are 1.25 moles of Ferri and 1.88 moles of Oxy in the formula of FeXOY.
But how can we have a quarter or half of an element?
Don't worry, now we see the ratio between Ferri and Oxy is 1.25 to 1.88. To find their smallest whole number ratio, we divide both 1.25 and 1.88 by the smallest number, that is 1.25. And we get 1 Ferri to 1.5 Oxy, but we are still not done. We have to multiply both numbers by 2 to clear the decimal of 1.5, and to produce the whole number values ratio, which is 2 Ferri to 3 Oxy. So our empirical formula of Ferris and Oxys is Fe2 and O3, which means we have 2 Ferris and 3 Oxys in the group FeO. Now let me explain molecular formula to you. Molecular formula is the symbolic representation of the actual number of atoms in each element. To find molecular formula, we need the percent composition and the molar mass of the compound group. Can I have carby, hydri, and nitri up here? In this example, we have 74% of carby, 8.7% of hydri, and 17.3% of nitri. The molecular mass of C, X, H, Y, and Z compound is 162 grams. To find the molecular formula, we first need to find the mass of each element out of a total mass of 162 grams. We get 120 grams of carby, 14.1 grams of hydri, and 28 grams of nitrate following the sig figs rule. Then let's meet our lovely Mr. Moley again. According to Carbies, Hydries, and Nitres student cards, there are 12.01 grams of Carby in 1 mole of Carby, 1.01 grams of Hydri in 1 mole of Hydri, and 14.01 grams of nitrate in 1 mole of nitrate. From this, we can calculate that there are 10 moles of Carby, 14 moles of Hydri, and 2 moles of nitrate in C, X, H, Y, and Z. So the molecular formula is C10, H14, and N2. Since the molecular formula shows the actual number of atoms in the compound group, we don't need to do any simplifying. This is the end of today's class, elements. Have a nice and chemi-molified day.